Again, line E, probability of more than one event, page 58. We're going to look at that little half sheet up at the top. All right, so important for these notes that this is all about doing more than one event, more than one event. So in our past notes, our past practice, we've been doing events that involved picking one card or rolling a die once or picking one item out of a bag. That was all one event. Now we're doing something where we're doing more than one thing. So we're maybe taking two cards, or picking two marbles out of a bag. And other examples that involve anything that's 2, 3, 4, or more events. When we have multiple events, they can either be classified as independent or dependent. So let's look at independent. So if we're talking about an independent event, that means it stands on its own. It's not affected by anything else. So independent event, the first event does not affect the next event. It does not affect.
And we're highlighting this because when I look at your notes, when I enter this in the grade book, I do enter these in the grade book. I'm looking for that. But there are some things in here.
Oftentimes, when we are talking about independent events, we will see us say stuff like replace an item or put it back. It's not always going to say that. But if we're putting something back or nothing is being taken away for the next event, it's independent. Now for this formula, something we got to address, we are talking about A and B. A and B, but this is different than when we had an and for one event. So when we're talking about two events, we're seeing does event A happen and then event B happen. So at two different times. When we're doing one event in our notes from Wednesday and our practice yesterday, when we said A and B, we were looking to see does that one event meet both requirements at the same time, like picking a 7 and a spade. Well, there's only one card that is a 7 and a spade, and it's the 7 of spades. But we're only doing one event there. So two events, and is two separate events happening. Event A, and then event B. Whenever we have multiple events, we're going to multiple events, we're going to multiply our probabilities. So multiple events, we're going to multiply the probabilities. When we look at the next type, we are looking at dependent. So this time, dependent, and event is going to depend on another one. It's going to be affected or influenced by a different event. So when the first event influences the next event, that's dependent. And again, oftentimes, not every time, but often we'll see us keep the item. So like if someone goes to pick a card and they keep it, now when the next person takes a card, there's one less card for them to choose. If I say, Kimmy, pick a card, and you get the ace of spades, and then I go to Abby and say, Abby, pick a card, Abby does not have a chance to get the ace of spades anymore because Kimmy kept it. So it's affecting a new probability. So for this formula, we're still going to be multiplying because we are doing multiple events. Multiplying because multiple events are happening. But this time, this second part looks a little bit different. It just means that we're looking for the probability of event B, knowing or given that event A already happened and it was kept. So event A might be Kimmy picking that ace of spades, and Kimmy keeps it. Event B would be Abby picking a card, knowing that Kimmy is keeping that ace of spades. So Abby doesn't have a chance to get the ace of spades in. So that is dependent. So let's take a look at those 3 steps on the left side of your notes, because we're going to need to do this every time we see that we're doing multiple events. So as you're reading through the problem, you're going to read carefully, and you see that we're doing 2 or more things. That means you need to decide, is this an independent event or a dependent event? Are our 2 events being affected by one another? Or can they stand on their own? Are we replacing an item? Are we keeping an item? Once we decide on that, we're then going to do our probability separately for each event. Find out event A. What's the probability of event A? Put it to the side. Find out the probability of event B. Put that to the side. If you have a third event, event C, or so on, do them separately. Then at the very end, you're going to multiply your fractions, multiply your probabilities, because multiple events, we multiply. Bless you. All right, so let's take a look at number 1. You randomly select 2 cards. Highlight that. 2 cards from a standard deck of 52 playing cards. So we have 2 events here. We're picking 1 card, and then we're picking a second card. 2 different events. What's the probability that both cards are hearts when you put the first card back in the deck before picking the next card? So since we have 2 events here, 2 different events, we need to first decide, is it independent or is it dependent? So are we replacing it? Are we keeping it after the first event? Is that going to affect our second event? So what do we think this event is? Is it independent? Is it dependent? Here, the mumbling. The second one? Dependent? Do we agree, is this dependent? Thumbs up yes, thumbs down no?
Dependent means that the first action changed something about the second action. So if we put the card back, did it change anything? So then I ask you again, is it independent or dependent? Independent variable or independent is when it does not affect the next. Dependent, it will affect it. Independent, they stand on their own.
So what do we think? All right, a couple more of us saying independent. Do we agree with independent, or do we want to go back to dependent?
Okay, just real quickly what you're thinking before we have our final answer. Listen to the difference again. So it says independent is when the first event does not affect the next event, like when you replace an item. So again, you're asking yourself, was the item put back? Dependent is when the first event influences or changes the next event, like when you keep an item. So again, did we keep it or did we put it back? That's what you're kind of thinking about, and then you're making the decision. So, folks, can I ask you guys one more time? I want final answers.
So independent or dependent? There's like 2 people. Let's all say it together. Is it independent or is it dependent? Let's try one more time. Independent or dependent? All right, a lot of us are sleepy today, I guess. This is
This is the first step.
Independent.
If you don't know the difference between independent or dependent, it will change your outcomes. What are the odds? How do you know? Okay, these are independent. We put the card back. It did not change the event. Event 1 and event 2, they're independent of each other. 1 did not change 2. The card was put back. Replace, put back. Replace and put back. This is independent. Make that note. Again, pick a heart, and then the second time, Jalen, we're going to pick a heart again. We're going to find out what are the odds? How likely is it?
All right, so we're choosing independent because we are replacing the card. So when our second card is picked, nothing changed. You take a heart, you put it back, you can still get that heart again. So it's independent. So now we do step 2, each event separately. So let's start with this first event, the first heart. So let's think about our standard deck of cards. How many hearts are in a standard deck of cards? 13, yeah. So 13 hearts you could get out of how many possible cards? 52. So 13 over 52 is our first event. Now we're going to do the second event separately. So let's say Kimmy took a heart and put it back in. Now we got our standard deck of cards, all the cards in them still. We put that heart back. Now what's our chance to get a second heart? How many hearts are there? There's still 13. Out of how many total cards? 52. So the second event is also 13 over 52. All right, so those are our 2 events. We did the probabilities separately. Now step 3 says to multiply our fractions. Multiply to find the probability of all events happening. And, what do you mean? Oh, what? What is this? So we're going to multiply our events, and I would recommend using that ABC button when you do your multiplying of fractions. So I would do 13 ABC 52 times 13 ABC 52. Let me know if you do not have a calculator in front of you. We need to know how to plug this stuff in on our calculator. More calculators here if someone's missing one. Everyone's got one in their hand. All right, when we do 13 ABC 52 times 13 ABC 52, what do we get? 1 over 16. 1 over 16. That is our simplified fraction. The chance of getting a heart, putting it back, getting another heart is 1 out of 16. 1 chance out of 16. So in theory, if you do this 16 times, one of those times you should get a heart and then another heart. All right, what questions do we have on number 1?
Again, the only real thing is, since these are independent, didn't change the outcome, step 1 versus step 2, trial 1 versus trial 2. And again, what's the lesson? We're multiplying. Yesterday we added our fractions, we subtracted the overlap. Today we're talking about multiplying these fractions. So let's look at another example. So we have 1 event, 2 events. Our first thing is we gotta look at this and decide, are these event 1 and event 2 independent from each other, or are they dependent?
So as part of a board game, you need to spin the spinner, which is divided into equal parts. if we're trying to find the probability of getting a 5 on our first spin, and then getting a number greater than 3 on our second spin, how many events is this? How many events are we doing? 2. We're spinning it twice. 2 events. So we're doing multiple events here. We need to decide, are those 2 independent or dependent? Is the first event affecting what happens in the second event, or are the 2 events standing on their own? What do we think in this example? Independent or dependent? I heard a couple. Independent, do we agree with independent? Thumbs up, yes. Thumbs down, we think it's dependent. We disagree, it's dependent. Okay, I think the room is split. Looks like we're split 50-50-ish. So if we think it is dependent, those that had the thumbs down, they disagreed. We think it's dependent. What is changing from our first to our second event? Why is it dependent? What's affecting our second spin? The first spin, how are we affecting it? If we spin their spinner and we get a 5, are we now taking the 5 out of the spinner? We are? We get a 5 and we take this section right here and we pull it out? No. So that means our second spin, the 5 is still there. We can still spin another 5.
Spinning a 5 does not change the spinner itself.
So
You're spinning it, bloop, and I spin it again, and the spinner stayed the same.
So this is another independent. Another I, independent. We didn't change anything from the first to the second spin. Nothing changed. Nothing was kept or taken out of our spinner. It's still the same spinner, still the same chance to get each number on our second spin. So independent. Now we need to, step 2, do the 2 events separately. So we're going to find the probability of us getting a 5 on our first spin, and then a number greater than 3 on our second spin.
Sorry, I didn't make a giant spin. I'm working on it. Okay, take some card.
All right, event 1. Event 1, spinning at 5. On our spinner, how many favorable outcomes are there? How many favorable outcomes? Just one. There's only one number 5 that we could get. Out of how many total outcomes are there? 8. So we have 1 out of 8 of getting a 5. 1 out of 8. All right, now we're going to do event 2 separately. Event 2, getting a number greater than 3. So on our spinner, what numbers are greater than 3? Let's list them out. What numbers are greater than 3 on the spinner? 4, 5, 6, 7, 8. Let's write that down up here. We've got 4, 5, 6, 7, and 8. Why not number 3? Why don't we want to include number 3? It's got to be bigger than 3, greater than 3. We don't want it to be equal to 3, so we don't really care about getting a 3 here. Anything larger than 3 is favorable. So 4, 5, 6, 7, 8. How many chances is that? 5 out of 8. So event 2, 5 chances of getting a number greater than 3 out of the 8 total outcomes. All right, now we did our events separately. Now we're going to multiply the fractions because we have multiple events. So we're going to multiply our fractions. Again, I would recommend using that ABC button.
I recommend that everybody do this because I'm having students make silly mistakes and you're gonna get freaked out if you don't know what to do.
If you're just sitting
Can I
there,
figure out my situation? Can I set up my situation and can I get the actual accurate calculation?
if you're just sitting there waiting for someone else to give you the answer, and then we go to take an assessment, and you don't know what you're doing, you're gonna think back to this moment of why you didn't try it on your own. So everybody should try 1 ABC 8 times 5 ABC 8, so that you can get your simplified fraction.
And if you don't remember this moment, I will remind you of this moment.
Here you go, Ryan, try it out. 1 ABC 8 times 5 ABC 8. What did we end up getting as an answer?
5/64.
I hear a couple 5/64. All right.
What a fun kind of combination. 5 times out of 64 times did it happen.
What questions do we have on number 2?
Again, there's more than one thing happening, and these are independent events. That means it did not change. What I did the first time did not change anything about the second opportunity. Don't worry, when we see examples of dependent, you'll be able to see the difference. In fact, you might notice how it's expressed when we look at this multiple choice question. Again, remember, we're multiplying our fraction. That's kind of really the lesson we want to pick up. Multiple events, we're going to be multiplying. Multiple events, we're going to be multiplying. But in order to set it up correctly, you have to know, is it dependent or independent? Dependent or independent, because that's how I'm setting up each event. So we're going to look at 3 different options, and which one or ones are independent events?
So again, think back to that definition of independent. Look up at the top where we did some highlighting. Independent means what? Someone read out that definition for us. Yep. First event does not affect the next event. ... What else do we say? What else is there? Like when you replace an item. So
And
let's.
that's the most important part, 'cause that's not how we would see it. They're gonna say, I replace it, or I put it back, right? Thank you, that's a very important piece to highlight.
So let's look at choice A. So we've got a bunch of snacks in front of us. And we go to pick up a bag of chips, and then we eat it. Then when we do our second event, we go to pick up a Gatorade, we drink it. Are those 2 events independent or are they dependent? Abby says dependent. Do we agree? Thumbs up yes, thumbs down no.
I got a few thumbs up, I'm seeing a few thumbs up, a few thumbs up, I'm seeing a few thumbs up.
Why do we say dependent for choice A? Why is this one dependent? You're not putting anything back. You're eating the chips. So there's no more chips to choose from when you go to do your second event. Like Desmond goes, picks up chips. Now there's no more chips for Desmond to pick for the second event. So now Desmond has to take the Gatorade. So that's dependent. This is not what we want. All right, choice B. Choice B. You're going to go and pick up a pop, and then you put it back. And then you pick up a water and put that back. All right, I'm hearing an independent. Do we agree that this one's independent? Or do we think this one's dependent? Couple thumbs up. Why did we say this one's independent? Because this time, you're picking it up and then you put it back.
Pick it up, you put it back, pick it up, you put it back, pick it up, you put it back, you put it back, 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 you put it back, independent.
So Noah goes and picks up a pop, realizes, oh, that's not the flavor I like. I'm going to put it back. So now there's still the same choices for the second pick. So this one is independent. All right, but we don't want to stop there because there could be multiple correct answers. So let's check choice C. All right, you pick up a bag of chips and eat it. Then you pick up a pop and put it back. Is this one independent or dependent? So Abby's again saying dependent. Do we agree? Thumbs up, yes. Thumbs down, no. Is this one dependent? Couple thumbs up. All right, why do we think this one's dependent? Because you what? You ate the bag of chips. You ate the bag of chips. Now when you do your second selection, you go to pick up the pop, there's no more chips to choose from because you already ate it. So C is not independent. Because what we did on the first selection changed what we can pick from on the second selection. So it's not independent. So only choice B is independent here. All right, let's jump up to the top right now and look at number 4. All right, number 4, you randomly select 2 cards from a standard deck of 52 playing cards. Again, 2 cards are being picked. That is 2 events. What's the probability that both cards are hearts when you keep both cards this time? So this time we're keeping the cards.
You can probably anticipate how it's going to change. You're probably already thinking ahead. The situation's different than on the opposite side. We picked a card, we put it back. We picked a card, we put it back. This time, we pick a card and we keep it.
All right, I heard a dependent. Why is it dependent? Because we're keeping the item. Yep, keeping it. So we're choosing dependent. And we want to find out the probability of us picking a heart, keeping it, picking another heart. So again, we're going to do each event separately. So let's start with event 1. Jakari, what's up with that phone? Event number 1. Picking a heart. So I got my 52 cards. Shaylia, how many cards are hearts that you can pick from? 13. Out of how many total cards? So the chance of getting a heart the first time is 13 out of 52. 13 chances out of 52 of getting the heart. Event 2. Now this time, Shaylee is keeping the card. We're not replacing it. So the card is kept. So now, when I go to tie, and I say, go ahead and pick another heart. How many hearts remain in the deck if Shaylee kept one? 12. Now there's 12 left over. Out of how many cards are there to pick from this time? 51. Because again, Shaylee kept that card. So now there's only 51 left over for Ty to pick. So she picked one and kept it. Now we're doing the second card, and we're going to keep this card. So if we picked a third card, it'd be out of 50. And if we keep keeping the cards, there's going to be less and less left over for you to pick from. All right, so we did our 2 events separately. Now we're going to multiply these fractions because there are multiple events. Again, I would recommend using your ABC button. 13 ABC 52 times 12 ABC 51. Give me a thumbs up once you have an answer in your calculator. More, do you have a calculator?
So we know, because if you don't have enough calculators, that's my job, what should we do? And come on, let's
All right, I'm seeing that most of us all got our answer. So what do we get as an answer? 1/17. 1/17. questions do we have on number 4? All right, number 5. We've got a bag with 5 red, 8 green, and 3 blue marbles. Imagine these black ones are blue.
Yes, it's been my sorry.
Find the probability of selecting a blue and then a red marble from the bag if you do not replace the first before drawing the second. So we are not replacing. And again, we are doing the first marble and then the second marble. So 2 events are happening. We are not replacing after the first one. So do we have an independent or a dependent event here? Dependent, because we're keeping it. We're not replacing the first marble. So dependent. So we're going to find the probability that our first marble is blue. And then our second marble is red. We're saying it's dependent. That means that when we do our second event, it's going to be influenced or affected by the first one. Alright, so let's start with our first event. Picking out a blue. How many blue marbles do we have the chance of picking from the bag? Just 3. Out of how many total marbles are in the bag? 16. How did we get 16? Yep, add all 3 numbers up here. So 5 red plus 8 plus 3
Good morning, Falcon Geometry. How may I help you?
is 16 total marbles. So we only have 3 chances
I
to
do.
win blue out of our
Yep, I'll send that to you
16
with a pass, no problem.
total
Thank
marbles.
you. Bye.
Alright, so event number 1, I give the bag to TJ.
That's for me.
And TJ
Yeah.
picks out a blue. And TJ keeps the blue.
Good morning, Falcon Geometry. How may I help you?
Now, I go and
Hi,
give
how
it to
are you?
Talia. How many remaining marbles
Yeah,
are
yeah,
there?
I'm sitting with a
TJ
inside
kept
this
one.
jacket.
15.
So can I? Yeah,
So
perfect.
it's going to
What's
be
the
out
number
of
for you?
15 chances.
1, 3, 4. C. No problem. I'll send that student down with a pass.
How many red ones
Thank you
are
so
left?
much. Thank you. Bye.
How many red ones are there? If TJ took a blue on the first one and kept the blue, then there's still 5 red. TJ didn't take a red marble. So there's still the 5 red in there for the second event. So now when TJ takes the blue and keeps it, Talia's only got 5 chances out of the 15 remaining for red. Alright, now we're going to, again, multiply our fractions because we're doing multiple events. Using that ABC button, so 3 ABC 16 times 5 ABC 15. And then give me a thumbs up once you have an answer. Did you get an answer, or are you waiting for someone else? All right, what do we get as our answer? 1 over 16? One over 16. All right, what questions do we have on number 5? last one here. We're gonna play a game that involves drawing two numbers from a hat. So again, two events are happening. We're picking one number from the hat. We're picking a second number from the hat. So two events. In that hat, there are 25 pieces of paper numbered 1 to 25. So 25 numbers, 1 through 25. Find the probability that you will draw a 3 on your first draw. Keep it. And then draw a number greater than 10 on your second draw. So is this independent or dependent? Why is it dependent, Abby? Because again, we're taking one guy and then we're keeping that. So when we go to take the second number, our second event, there's a different probability, there's a different amount of pieces of paper left over. So dependent. Alright, so we're finding the probability of picking out a 3, and then a probability of getting a number greater than 10. Whoa. Alright. Event number one. Event number one. I got my hat with the papers in it. And Brenda's going to take out a 3. How many 3s are in that hat? Just one. Only one 3. So Brenda's going to reach in, grab that 3. How many chances could she have gotten, or how many papers could she have taken? There is one 3, but how many total papers could she have taken? 25. So Brenda had 1 out of 25 of getting that 3. One chance from the 25 numbers of getting that 3. Now for event 2, Brenda's taking that 3 and Brenda is keeping it. So Brenda kept that 3. Now when Chloe goes to take a number, how many numbers are left for Chloe to take? 24. Because Brenda kept one of them. So there's 24 left over. And Brenda's number was the number 3. Is that number greater than 10? No. So Brenda's 3 does not affect how many numbers greater than 10 there are. Only the remaining total. So when Chloe goes to take a number greater than 10, how many chances does she have? 15? Well, if you need to write it down and count it out, we got 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That's 15. So we have 15 chances out of our remaining 24, because Brenda kept one of them. So now there's only 24 left for Chloe to get that number greater than 10. Alright, so now we're going to multiply because we have multiple events using that ABC button. So 1, ABC 25 times 15, ABC 24. Give me a thumbs up once you have an answer. Need a couple more thumbs up. We got our answer. Okay, what do we get as our answer? 1/40. So 1 chance out of every 40 attempts, we're getting that 3 and then a number greater than 10.
I'm gonna reach over there. Try not to get in your space.